Hello, good evening, students. Good evening. Give me the clearance, please. Hello, good evening, students. Good evening. Am I audible and visible? Give me the clearance. Okay. So, very good evening to all of you. Welcome to Unacademy. Dr. Khalil here. Operating System course. Good evening, Sunidhi. तो हमारा टॉपिक ऑफ डिस्कशन चल रहा है सीपीयू शेड्यूलिंग पर. आज का हमारा नेक्स्ट सेशन होगा सीपीयू शेड्यूलिंग टेक्निक, जहां पर हम स्टार्ट करेंगे प्रायोरिटी बेस्ड शेड्यूलिंग और अदर कंटिन्यू फ्रॉम द प्रीवियस सेशन. तो आज का एजेंडा हमारा होगा प्रायोरिटी बेस्ड शेड्यूलिंग प्लस राउंड रॉबिन और कुछ प्रॉब्लम सॉल्विंग भी करेंगे इसमें. ठीक है, तो चलो लेट्स कंटिन्यू विदाउट एनी डिले. So before round robin, let me just talk about the name of the title. We'll write CPU scheduling. And the next scheduling technique priority based scheduling. So the criteria here in priority based scheduling would be what is called the priority of the process. तो आपको जैसा पता है, हमने डिस्कस किया था, priority is one of the attribute of a process. Priority is generally assigned to the process at the time of creation as the initial value. और उसके बाद we can basically keep on either changing the priority or the priority remain the same. अगर priority of the process is not changing, that is called static priority. और अगर gradually priority increase हो रही है at regular intervals of time, तो हम उसे कहते हैं dynamic priority. तो यहाँ पर since we are solving the problem, so therefore it should be considered as static priority. So essentially the selection criteria, let us write selection criteria is a priority. ठीक है, priority is assigned, as I said, normally as an integer value, and this integer value is computed by means of a function taking several parameters, like the priority, the parameters could be like type of process, or maybe size of process, and the number of resources that the process is using, number of resources. ठीक है, that would be considered as the several parameters which we can consider for computing the priority of the process. अगर operating system process हो, priority would be high, user process may have lower priority, foreground process may have high priority, background process may have low priority, right? Backup process will have low priority, student process will have low priority, and faculty process may have high priority. So like that, different parameters will govern, और हर एक parameter को we can assign different weightage, and then we can compute priority as an integer value. And after the priority is assigned as an integer value, we can have two conventions: higher number, higher priority, lower number, lower priority. We can have either of these conventions. जैसा number बड़ा हो, priority में भी high, number छोटा हो, priority में भी low. Or sometimes we have seen they follow a reverse convention: lower number, higher priority. They say higher number, higher number, lower priority. So essentially what I wanted to say कि आपने एक पेपर में देखना होगा, एग्जाम के क्वेश्चन में देखना होगा कि what is the convention follow, because generally they will mention the convention in the question. क्वेश्चन में आपको बता दिया जाएगा कि कौन सा कन्वेंशन बाय फॉलो किया जा रहा है. So by default there is no standard convention like it. So here I'm going to follow higher number, higher priority, lower number, lower priority. And mode of operation, boys and girls, the mode of operation of this scheduling technique, is either preemptive or it can also operate in non-preemptive. It can operate in both the modes. It can operate in preemptive mode as well as non-preemptive mode, either of these. And boys and girls, I would like to emphasize that the working of this scheduling technique is exactly like SJF. So therefore, I would say priority exactly works like SJF and SRTF. By default, SJF is non-preemptive and SRTF is preemptive. So it works essentially just like SJF. जिस तरह SJF work करेगा उसी तरह priority भी work करेगी, except that in SJF we look into burst time, यहाँ पर हम priority देखेंगे. So decisions are made by looking into priority. There the decisions are made by looking into burst time. That is the only difference. Otherwise, essentially both of them are same. तो हम क्या करेंगे, एक example लेंगे and then we will work out. We will produce, show the Gantt chart using non-preemptive and preemptive based priority scheduling. So let's take a sample data set. So imagine, for example, this is the priority of the process and this is the process number, arrival time and burst time. Okay? So process number 1, process number 2, process number 3, 4 and 5 processes. And their arrival times are something like this: 0, 2, 4, 5 and 7. You can take some sample burst times, say for example 3, 5, 4, 2 and 6. And here we follow the priority. So let's say the priority is 4, 5, 8, 7 and let us say 6, like this. So how will the Gantt chart look like for priority based scheduling using non-preemptive and preemptive approach? So let us produce the Gantt chart. Let us draw the Gantt chart for both of them. So I will first draw the Gantt chart for non-preemptive based and then preemptive based. तो यहाँ पर हम बोलेंगे this is non-preemptive based, non-preemptive priority. So this is CPU. Time starts at 0 as usual. How many processes are available at 0? There is only one process P1, so we don't have any option other than starting with P1. So हम start करेंगे P1. Burst time requirement is 3. It is going to run up to 3. Non-preemptive. Now at time 3 or by time 3 we have only P2. देखिएगा P3 is coming at 4, P4 is coming at 5, P5 is coming at 7. So naturally we cannot consider these 3 processes. तो हमें schedule करना पड़ेगा P2 को ही. So P2 needs 5 units of time. 3 plus 5, 8 पर complete कर पाएगा. Now by this time remaining all processes are available, P3, P4, P5 और इसमें जो higher number priority है वो है P3, 8. Because I am following the natural convention that higher number higher priority, तो ये higher number है 8, that is higher priority. So naturally इसके बाद P3 ही schedule होगा और उसका burst time है 4, so 8 plus 4, 12. इसके बाद next highest priority है P4 की है, so P4 will take the charge. P4 need 2 units of time, so complete at 14. And then later lastly P5 is pending, so therefore P5 will take. So it so happened accidentally that it is following in the same schedule. So it needs 6 units of time, 20. This is the Gantt chart. This is the Gantt chart. Non-preemptive. अब on the other hand इसका हम preemptive version देखेंगे and see the difference, what is going to happen. See the difference. So let's draw the Gantt chart using preemptive version of priority. So let us write it here, preemptive priority. Preemptive priority. Okay? So what is going to happen in preemptive priority? So let's follow carefully. At time 0, we are going to start with process P1. P1 run करेगा till arrival of next process. Next process arrive हो रहा है at time 2. At time 2. So at time 2, P2 is coming with a requirement with a priority of 5 and 5 is greater than 4. So यहाँ पर P1 preempt होगा in favor of P2. P2 similarly will run till 4. At time 4, P3 comes with a priority of 8 and that is the highest priority and that is going to enforce preemption in favor of P3. P3 इसलिए कि इसकी priority highest है 8, so it is not going to get preempted. मतलब वो सारे 4 यूनिट के लिए 4 यूनिट्स के लिए रन करेगा. So at time 8 it is going to finish. At time 8 P3 is going to finish. Now by this time remaining all process are completed. तो अब हमें select करना होगा जो process जिसकी priority highest है. So process P4 की priority highest है. P3 के बाद P4 run करेगा non preemptively because no new process is come. So therefore it is going to complete at time 10. अब P4 के बाद next highest priority 7 के बाद 6 ही है P5. P5 भी run करेगा for 6 units 16 पर complete कर देगा. इसके बाद देखिएगा P1 and P2 has some balance. P1 and P2 has some balance. कितना balance है उसका verify करिएगा. P1 ran for 2 units, इसका balance है 1. P2 ran for 2 units, इसका balance है 3. So among these are the two processes left over, P1 and P2. सुनिएगा, P1 and P2 are the two processes left over. तो इन दोनों में higher priority किसकी है? P2 की है. So P2 will take the charge. P2 will take the charge. Is it not? P2 will take the charge and run for remaining 3 units, 19. And then finally P1 will take the charge, runs for its balance 1 unit, 20. तो देखिएगा completion time 20 and 20, but number of preemptions are different here. Number of preemptions are different. So this is the ideology of non-preemptive and preemptive based scheduling. There were questions asked in earlier papers based on this algorithm. और एक one of the important gate question जो पूछा गया था based on preemptive priority based scheduling with sort of dynamic approach. Let us try to work out that PYQ. वो PYQ आंसर करने से काफी आपका कॉन्फिडेंस लेवल भी बढ़ेगा. So let's, boys and girls, quickly go to that PYQ question which was asked in one of the paper earlier based on priority based scheduling. So let me show you that question here. This is a question. I want you to have a look at this question. This is one of the finest question which was asked in earlier paper of GATE based on priority based scheduling. Let us see whether you can answer it. I'll give you a minute of time. Can you please prepare the Gantt chart for this data set? For this data set, I would appreciate आप अच्छी तरीके से क्वेश्चन को रीड कीजिएगा and then you try to give your response. It's one of the very interesting and one of the very important problem PYQ asked in previous paper of GATE. Consider a system with preemptive priority based scheduling. So therefore this is preemptive priority based scheduling. Let me tell you that in actual GATE paper perhaps this question was answered correctly by less than 5% students. That is the importance of this. So if you could solve, so then that means your comfort level, your confidence level with respect to CPU scheduling is good. तो चलिए यहाँ पर देखेंगे. Preemptive priority based scheduling with 3 processes P1, P2, P3 having infinite instances. ये काफी important है. There are 3 processes लेकिन number of instances of them are infinite. मतलब P1 के कई instances है, P2 के कई instances है, P3 के कई instances है. और वो instances कैसे आ रहे हैं? What is the rate of their arrival? Let us see this. The instances of these processes arrive at regular intervals of 3, 7 and 20. जो periodic interval है with which the instances of the process are coming at a rate of 3. मतलब अगर मान लीजिए if P1 is coming, first instance is coming at 0, उसका next instance बेटा कब आएगा? 3 पे आएगा. Next instance कब आएगा? 6 पे आएगा. Next instance कब आएगा? 6 plus 3 9 पर आएगा. Next 9 plus 3 12 पर आएगा. इस तरीके से infinite instances of P1, P2, P3 P1 है. फिर उसी तरह the rate of the arrival of process P2 is 7. मतलब first instance of P2 second process is at 0. तो next instance आएगा 0 plus 7. Next instance आएगा 7 plus 7 14. 14 plus 7 21. इस तरीके से आएगा. उसी तरह last process उसकी जो arrival rate है at the rate of 20 है. First instance at time 0. Next at time 0 plus 20. 20 plus 20, 20 plus 20, like that it adds on. Okay, the priority of the process instance is the inverse of the period. मतलब priority of P1 is 1 by 3, inverse, reverse. P2 1 by 7, P3 1 by 20. So that is the inverse of its period. फिर उसके बाद देखिएगा Each of these process instance P1, P2, P3 consume 1, 2 and 4 millisecond of CPU time respectively. मतलब burst time of P1 1 unit, burst time of P2 2 units, burst time of P3 4 units. मतलब हर एक instance consume करेगा time of CPU 1, 2 and 4. Very good. The first instance of each process is available at 1. हमने कहा 0, यहां पर दिया गया है 1. First instance of the each process is available at 1, not 0. 1. So 1 से आप period add करना है 1 plus 3, right? 4, 4 plus 3 7, 7 plus 3 10, इस तरीके से. चलिए आगे देखेंगे. क्वेश्चन पूछा जा रहा है व्हाट इज द कंप्लीशन टाइम ऑफ द फर्स्ट इंस्टेंस ऑफ प्रोसेस P3. P3 का फर्स्ट इंस्टेंस कब कंप्लीट होगा? वेरी इंटरेस्टिंग क्वेश्चन, वेरी इंटरेस्टिंग क्वेश्चन. So if you try to work out, prepare the Gantt chart, then this will be very interesting problem to solve. तो चलिए सॉल्व करने की कोशिश करेंगे नेक्स्ट पेज पर. So सबसे पहले डेटा गैदरिंग करना होगा, हमें डेटा ऑर्गेनाइज करना होगा. तो कैसे करेंगे यहां पर देख लीजिएगा. We'll write process number, we'll write arrival time, right? And we will write the burst time instance. And here I said next instances. Next instances. एंड यहां पर हम लिखेंगे प्रायोरिटी. ठीक है, प्रोसेस 1 2 3. अराइवल टाइम ऑफ द फर्स्ट इंस्टेंस इज 1 1 1. द बर्स्ट टाइम रिक्वायरमेंट ऑफ द 3 प्रोसेसेस आर 1 2 and 4. ठीक है, प्रायोरिटी इज द रिवर्स ऑफ इट्स और इनवर्स ऑफ इट्स पीरियड. तो मतलब द प्रायोरिटी ऑफ P1 P2 P3 यहां पर जो होगी दिस विल बी 1/3, दिस विल बी 1/7, this will be 1/20, because the rate of P1 arrives at a rate of 3 units, P2 arrives at a rate of 7 units, P3's rate of arrival of the next instance is 20. तो 1/3 1/7 1/20. तो मतलब यहां पर अगर आप गौर करोगे, this is the highest priority, this is the lowest priority. 1/3 is higher value than 1/20, right? We are following the natural convention. इसीलिए priority is the reverse of its period. तो अब हमें Gantt chart बनाना होगा showing how the processes will get scheduled. चलिए start करेंगे. I am going to prepare the Gantt chart. Please follow carefully and try to prepare the Gantt chart. So imagine this is the CPU, and let's also imagine that this is the ready queue. This is a ready queue. This is a ready queue. Okay, Nirmal is trying to give the answer 27. Is the 27 correct answer, or shall I give a small amount of time for you, time quantum to work out? क्या आप workout करोगे? Those who are present in the class and interested in writing GATE exam, can you work out and let me know what is the completion time of process P3? P3 completes at what time? Come on, make a try. I'll give you 2 minutes of time. Make a try. What will be the completion time of process P3? That will be very interesting to work out. चलिए स्टार्ट कर रहा हूं मैं. 0 to 1 there is no activity on CPU. This is 1. Scheduling starts at time 1. Time 1 पर क्या होगा? All the 3 processes first instance will be available. So I am writing like this: P1 first instance, P2 first instance, P3 first instance. We are following this convention. P1 first instance, P2 first instance, P3 first instance. So who will get scheduled first? Among P1, P2, P3, higher priority is P1 first instance. P1 का burst time क्या है? 1 unit. So next instance यहाँ पर हमने नहीं लिखे, लेकिन let us try to write. So next instance of P1 will come at 1 plus 3 4. Next instance will come at 4 plus 3 7. Next will come at 10. Next will come at 13. Like that it goes infinite. उसी तरह P2 का next instance आएगा at a rate of 7. So 1 plus 7 8. 8 plus 7 15, and like that it goes. P3 first instance at 20, next will come at 20 plus 1 21, next will come at again 20 40 41, and so on it goes. Like that it goes. So you'll have to be following this ideology. The rate at which the instance will come is 3 7 and 10. So one first पे available है, first से आपको 3 units लेना होगा. From first instance onwards you have to. Vani is saying 27, Nirmal is also saying 27. Let us see whether 27 is right or wrong. So have a look on board, boys and girls. So P1 first instance need 1 unit of time, so it will complete at time 2. It will complete at time 2. So P1 first instance is over. इसके बाद कौन शेड्यूल होगा? P2 and P3 में हायर प्रायोरिटी है P2 की. P2 first instance will run, कितने टाइम के लिए रन करेगा? 2 यूनिट्स. So at time 4 P2 is going to complete. At time 4 P2 is going to complete. So P2 first instance is over. अब P3 was about to get scheduled, लेकिन क्या होगा? तो सुनिएगा, at time 4 new instance of P1 will come. P1 second instance will join the ready queue और P1 की priority higher है, तो मतलब ये हुआ P1 is going to run. P1 second instance is going to run for 1 unit 5. इसके बाद क्या होगा? At time 5 P1 second instance is over. So only P3 is available, so P3 will start first instance. Boys and girls, please remember that this scheduling technique is preemptive priority. This is preemptive priority. तो मतलब preemption होगा when I get a high priority process. Is it not? When I get a high priority process, preemption होगा. तो सुनिएगा आप क्या होगा यहाँ पे. P3 can continue only for 2 units 7. क्यों? क्योंकि at time 7 new instance of P1 will come, P1 third instance, and here P3 is going to get preempted. P3 is going to get preempted. And the control is given to P1. P3 is there in the ready queue, control is given to P1 third instance. It will run for 1 unit and complete at 8. ठीक है? यहां तक क्लियर है सभी को? Is everybody clear with this? So P1 third instance complete at time 8. So let us complete it. अब इसके बाद क्या होगा? Exactly you see at time 8 P3 was about to run, लेकिन P2 has come. P2 second instance has come. So that is having higher priority than P3. So P2 run करेगा second instance. कितने टाइम यूनिट के लिए? 2 यूनिट के लिए. 10 तक कंप्लीट कर लेगा. So P2 is going to complete at time 10. P2 second instance. At time 10 again P3 was trying to run on CPU. P3 try कर रहा है, लेकिन क्या होगा? लेकिन फिर again at time 10 P1 का new instance आ जाएगा, P1 fourth instance. तो that is having higher priority. So P1 fourth instance is going to run for 1 unit 11. 11 पर P1 का fourth instance complete हो जाएगा और उसका नया इंस्टेंस फिर आएगा 13 पर और P2 का नया इंस्टेंस आएगा 15 पर. राइट नाउ टाइम इज 11. तो ओनली प्रोसेस अवेलेबल रेडी क्यू P3 है. So P3 रन करेगा फर्स्ट इंस्टेंस. अर्लियर P3 ran for 2 units. Now P3 again need 2 more units to complete its first execution. So therefore P3 का total burst time requirement 4 है. तो यहां पर देखिएगा P3 here in the earlier run could run only for 2 units. तो उसके बैलेंस 2 units है. तो बैलेंस 2 units now it is going to run and complete at time 13. At time 13 P1 comes, so P1 is going to run. लेकिन क्वेश्चन पूछा गया था कि what time P3 is going to finish its execution. First instance of P3 is going to complete at what time? So therefore the answer for this, so here you can check. P3 got completed at time, P3 first instance got completed at time 13. So boys and girls, this is the completion time of first instance of P3 first instance, and that is the answer. तो सुशांत एंड निर्मल, तो आप चेक कर लीजिएगा बेटा आपने क्यों रॉन्ग किया और कैसे रॉन्ग किया. ठीक है, कैसे, व्हाई डिड यू गॉट रॉन्ग और वेयर हैव यू मेड द मिस्टेक, यू शुड वेरीफाई फ्रॉम दिस आंसर. अभी अगर स्टार्ट करोगे गेट प्रिपरेशन फ्रॉम स्क्रैच 74 प्लस, बिल्कुल पॉसिबल है. You can spend consistently and with a full enthusiasm, then definitely it is possible to score 70 plus marks and get a single or double digit rank. Definitely, why not? I have seen people in my career so far, I have seen people preparing for 3 months, preparing for 4 months and getting single and double digit rank. That's possible. That's possible. Only a dedicated action plan and a consistent effort, a hard work is needed from your side, and definitely a good mentoring is also important as far as GATE exam preparation is concerned. अगर आपको अच्छी mentorship मिले और अच्छी consistency हो आपके पास तो आप जरूर कर सकते हो. ठीक है, चलिए अब नेक्स्ट हम आगे बढ़ेंगे and we will try to go for round robin scheduling. ठीक है, राउंड रॉबिन शेड्यूलिंग में प्रॉब्लम देखेंगे और उसके भी न्यूमेरिकल्स देखेंगे. Priority based scheduling we completed just now. Okay. So here is round robin. So let us discuss it. So let us write that a very important, super duper important topic. Sixth scheduling technique, round robin. We will generally write in short RR. This was the scheduling technique which was generally used in multi-programmed time sharing systems. जो initially time sharing systems थे, this scheduling technique was prominently used. Let us write about the facts about round robin. The selection criteria for this is selection criteria for round robin is arrival time of the process plus a parameter called time quantum. Some people call time quantum, some people call time slice. Both are essentially same. So we'll say TQ as time quantum. Time quantum and time slice, both are essentially the same. Okay. So idea is every process which is scheduled onto CPU is scheduled on FIFO order, first come first serve order, just like first come first serve. Like in first come first serve was non-preemptive, but round robin is preemptive. Round robin is preemptive, and preemption is based on the allotment of time quantum, expiration of time quantum. Every process that gets scheduled onto CPU is allowed to run for not more than the allotted time quantum. वो time quantum जो allot होगा, within that if the process is getting completed, well and good, it will leave the CPU. Within the time quantum, if the process need to go for IO, फिर भी छोड़ देगा CPU को, then it will go for IO. लेकिन अगर ना ही process complete कर रहा है, ना ही IO के लिए जाएगा within the time quantum, then after the time quantum is over, after the time quantum expires, then the running process will be forcibly removed from the CPU. Will be forcibly removed from the CPU. Forceful deallocation from CPU. That is called expiration of time quantum, causing the process to relinquish the control of CPU. Causing the process to relinquish the control of CPU. The operating system forcibly remove the running process, put it back to the ready queue, because हमने process state transition diagram में देखा था कि जब भी कोई process timer interrupt से preempt होगा, it will go back to the ready queue. Means it is saying that no, okay, now you are preempting me, no issue, but later on again I want to run. Again I want to run. Then whichever process is in the line in the ready queue, that will get a chance to run on CPU. इसी तरह processes are going to continue and complete their execution in a round robin fashion. This is the basic ideology or the philosophy of round robin scheduling. So चलिए start, and the mode of operation is essentially preemptive. The mode of operation is essentially preemptive. Mode of operation is essentially preemptive. तो एक एग्जांपल लेकर ट्रेस करेंगे हाउ इट वर्क. देन विल सी सम PYQs आल्सो, प्रोसेस नंबर, अराइवल टाइम, बर्स्ट टाइम. ठीक है. So 1, 2, 3, 4. First I will take a very simple direct data set. Then I will go for variable arrival times. So I will take all uniform arrival times here. Burst times are like 4, 5, 2, 3. Let's say time quantum is equal to 2 units. Let's say time quantum is equal to 2 units. So how will the processes get scheduled? So let's draw the Gantt chart here. Now round robin is a scheduling technique जहां पर आपको ready queue का status maintain करना होगा. Ready queue का status maintain करना होगा. This is ready queue and this is CPU. Time is 0. At time 0, we have all the processes P1 to P4. So let us put the processes in the ready queue P1, P2, P3, P4. So how will they get scheduled? So first I am going to run P1. कितने time के लिए run करेगा? 2 units time quantum. It will get preempted and put it back to the queue. Then after that P2 will run. कितने time के लिए run करेगा? 2 units again, 4, and it will be putting back to the queue. Next, who will run? P3. P3 need 2 units, time quantum is 2 units, so P3 is going to finish at time 6. P3 is going to finish at time 6. Then P4. P4 need 3 units, 6 plus 2, 8. and then P4 is going to get preempted. So here we'll have to add P4. P3 is already over. I don't have to add P3 again. Next to run is P1. P1 is going to finish at time 10. Then followed by P2. P2 is going to get preempted at 12 and put back to the queue P2 because P2 का requirement है 5 units और हमारा time quantum है 2 units. So P2 has run for two turns. Next P4 run करेगा. P4 has a balance of 1 unit. So therefore P4 is going to finish at time 13. P4 का requirement 3 है and P4 has run for 2 units and it has run for 1 more unit here. Last में P2 को भी चाहिए 1 unit, so it is going to finish at 14. This is the Gantt chart using round robin. ठीक है? So this was uniform arrival time. ऐसा हो सकता है कि you may have jumbled arrival times or you may have different arrival times. तो वहां पर आपको अराइवल टाइम का कॉन्सेप्ट मेंटेन करना इंपॉर्टेंट है. एक और डेटा सेट लेकर अंडरस्टैंड करने की कोशिश करेंगे, फिर उसके बाद परफॉर्मेंस एनालिसिस देखेंगे. सो हियर आई हैव प्रोसेस नंबर, अराइवल टाइम एंड बस टाइम. सो लेट्स से प्रोसेस 1, प्रोसेस 2, प्रोसेस 3, प्रोसेस 4. See on board. This is 0, this is 2, this is 3, this is 5. Bus times are something like 4, 5, 6 and 2. Let's say time quantum is equal to 3 units. How will the process basically get scheduled using round robin policy? So here I will take the ready queue and we will take CPU and show how it works. So let's go for the Gantt chart. This is ready queue. Okay? So see on board. At time 0 I have only P1. So कौन start करेगा? P1 ही start करेगा at time 0. Allotted time is 3 and burst time is 4. मतलब P1 रन कर पाएगा 3 यूनिट्स के लिए टाइम क्वांटम. अब जब तक 3 यूनिट्स के लिए रन कर पाया, by this time if you observe P2 and P3 have already made entry into the ready queue. P2 and P3. So P3 came at time 3 and at time 3 P1 is also trying to join the ready queue. हम लेकिन जो प्रोसेस ऐड करेंगे, जो हम प्रोसेस ऐड करेंगे, that will be the new process. Because round robin का जो basic objective है is to improve interactiveness. So already P1 has got a chance to run, so therefore we want to give the chance to new process P3. So P3 is going to take the charge first and then P1 will get preempted and put it back to the queue. तो बच्चों फिर से कह रहा हूं, समझने की कोशिश कीजिएगा. At time 3 2 events are happening. क्या है 2 events? One is basically the arrival of new process which is P3 and the other is P1 should also join the ready queue. मतलब दोनों contend कर रहे हैं. P1 and P3 are contending. So who should get added first? So that will be बेसिकली व्हाट इज कॉल्ड ए टाई ब्रेकिंग रूल. और हम यहां पर कह रहे हैं कि हम अपॉर्चुनिटी हमेशा न्यू प्रोसेस को देंगे. क्यों? क्योंकि राउंड रॉबिन की बेसिक आइडियोलॉजी है, बेसिक फिलॉसफी है टू इंप्रूव द इंटरैक्टिवनेस. लेकिन अगर एग्जाम में ऐसा दे सकते हैं तो दे मे से दैट इन केस ऑफ ए टाई बिटवीन प्रोसेसेस यू फेवर द प्रोसेस विच इज हैविंग लोअर प्रोसेस आईडी. ऐसा भी दिया जा सकता है, या फिर ऐसा भी बोल दिया जा सकता है कि फेवर द प्रोसेस विच हैज अराइव्ड फर्स्ट और फेवर द प्रोसेस विच हैज अराइव्ड लेटेस्ट. कुछ भी दिया जा सकता है. There is no hard and fast rule on which process should basically get onto ready queue. उसके लिए tie breaking rule देना पड़ेगा एग्जाम में and accordingly you will have to prepare the Gantt chart. तो चलिए we'll go along with this. So P2 is going to take the charge next. P2 का burst time है 5 and allotted time is 3 units. So 3 units के लिए रन करेगा. 3 plus 3 6. 3 plus 3 6. Now by time 6 or between 3 and 6 the next process to come is P4. यहां हम P4 ऐड करेंगे. फिर इसके बाद P2 preempt होकर रेडी क्यू में जाएगा. दिस ऑर्डरिंग इज इंपॉर्टेंट माय डियर स्टूडेंट्स. अगर ये ऑर्डरिंग आप मेंटेन नहीं करोगे तो फिर आप गैंट चार्ट सही तरीके से नहीं बना पाओगे, आपका गैंट चार्ट गलत हो जाएगा. प्लीज फॉलो दिस कॉन्सेप्ट. इन व्हाट ऑर्डर द प्रोसेस आर कमिंग, इन व्हाट ऑर्डर दे आर गेटिंग शेड्यूल ऑन टू CPU. That is essentially very important. So next to run is P3. P3 का requirement है 6, so it will run for 3 units. 6 plus 3 9. And now no new process is going to come, इसीलिए हम P3 को यहां पर ऐड कर देंगे. Next to run is P1 again. P1 has a balance of 1 unit, so it is going to finish at time 10. P1 finishes at time 10. फिर उसके बाद कौन रन कर पाएगा? P4. P4 का रिक्वायरमेंट जस्ट 2 यूनिट्स है. अलॉटेड टाइम है 3, लेकिन वो 3 यूनिट्स के लिए रन नहीं करेगा, 2 यूनिट्स के रन करेगा और कंप्लीट हो जाएगा. 10 plus 2 12. फिर उसके बाद P2 रन करेगा. Balance 2 units, so it is going to finish at 14. क्यों 2 units? Earlier P2 ran for 3, so 3 plus 2 5. P2 completes at 5. Then finally P3 take the charge. P3 earlier ran for 1, so now it is going to run and complete at 14 plus 3, 17. This is a Gantt chart. That's right, Yuvraj and Nirmal, the Gantt chart. And once you prepare the Gantt chart, आप चाहो तो एवरेज टर्न अराउंड टाइम, एवरेज वेटिंग टाइम, जो चाहो आप निकाल सकते हो. दिस इज द वर्किंग ऑफ राउंड रॉबिन शेड्यूलिंग. यस, दैट्स करेक्ट. युवराज सिंह इज राइट. अब बेटा इसके बाद हमें देखना होगा कि व्हाट इज द परफॉर्मेंस ऑफ राउंड रॉबिन. राउंड रॉबिन का परफॉर्मेंस क्या है, परफॉर्मेंस किस फैक्टर के ऊपर डिपेंड करेगा. चलिए नेक्स्ट स्लाइड पर हम वर्कआउट करने की कोशिश करेंगे. परफॉर्मेंस ऑफ राउंड रॉबिन. Performance of round robin invariably depends on time quantum. Time quantum can be selected as either a small value or a large value. It can be selected as a small value or large value. तो हमें ये स्टडी करना होगा कि what is going to happen if time quantum is small and what is going to happen if time quantum is large. क्या होगा? So let's try to analyze. अगर time quantum small हो, it will lead to more number of context switches. And when the time quantum is large, will lead to less number of context switches. Less number of context switches. And यहाँ पर if the time quantum is small, it will lead to more interactiveness. System become more interactive because every process waiting in the ready queue will get a chance earlier to run on CPU, more interactiveness. And here when the quantum is large, it will produce less interactiveness. System become poor interactive or poor responsive when the quantum is large. इसके contrary आप ये भी बोल सकते हो, what is going to happen when the time quantum become very small? बहुत ज़्यादा small value हो. And what happens when the time quantum become very large? Very large. If the time quantum become very large, round robin degenerates to work like first come first serve. Degenerates to work like FCFS. Is it not? It will work exactly like FCFS, which is not at all an interactive system. And when the time quantum is very small, efficiency of the system, because most of the time हम context switching करेंगे, so therefore efficiency tends to become nearly to zero. Efficiency tends to become nearing to zero when the time quantum is very small. So boys and girls, this is the performance of round robin scheduling. तो चलिए आगे बढ़ेंगे. With regard to some questions, some problems we will take. PYQs है based on CPU scheduling. Some interesting PYQs we have. Okay. So let's take up one question. This we have already seen earlier. हाँ, ये क्वेश्चन एक बार वर्कआउट करने की कोशिश करेंगे. प्लीज हैव अ लुक एट दिस प्रॉब्लम. प्लीज हैव अ लुक. This is one of the question, important question based on shortest remaining time first, SRTF. क्वेश्चन रीड कर लीजिएगा, फिर हम अटेम्प्ट करेंगे प्रॉब्लम सॉल्व करने की. This is one of the interesting question. युवराज, एजिंग मतलब यह है कि एट रेगुलर इंटरवल्स ऑफ टाइम आप प्रायोरिटी ऑफ द प्रोसेस इफ इट ग्रेजुअली इंक्रीजेस, जैसा पर्सन की एज है, टाइम के साथ साथ पर्सन की एज बढ़ेगी, एजिंग प्रोसेस. तो एंड रेगुलर इंटरवल्स ऑफ टाइम जब आप प्रायोरिटी ऑफ प्रोसेस इंक्रीज कर रहे हो तो लो प्रायोरिटी प्रोसेस हाई प्रायोरिटी बन जाएगा. तो ये प्रोसेस को हम एजिंग कहते हैं. तो एजिंग इज बेसिकली अ सॉल्यूशन टू ओवरकम द प्रॉब्लम ऑफ स्टारवेशन. जो प्रॉब्लम ऑफ स्टारवेशन होता है उसको एलिमिनेट करने के लिए हम एजिंग प्रोसेस यूज करते हैं, सो दैट at some point of time lower priority process would become high priority process. ठीक है. चलिए क्वेश्चन देखेंगे. Consider the following 4 processes with arrival times in milliseconds and their length of CPU burst in milliseconds. ये burst time है 313Z. These processes are run on a single processor using preemptive shortest remaining time first (SRTF) scheduling algorithm. If the average waiting time of the process is 1 millisecond, SRTF से average waiting time अगर 1 millisecond होना हो, अगर आपको चाहिए 1 millisecond average waiting time, then the value of Z is dash. तो पूछा ये जा रहा है कि जो value of Z, what is this value to get an average waiting time of 1 millisecond? Very interesting question. आपको 2 मिनट का टाइम दूंगा. I would like the students who are present in the class to please work out and tell me what is answer आपके हिसाब से, because this is one of the important 2-mark numerical answer type question. 2-mark numerical answer type. Come on, do it. 2 minutes of time. SRTF scheduling जो हमने already हमारे lectures में कर लिया है पहले. तो using SRTF scheduling, if you want the average waiting time to be 1 millisecond, then what should be the value of burst time Z, which is the burst time of the process P4? And let me tell you again, very few students could do it correctly. Very few students could do it correctly. 2 minutes of time, please try it. Any answers? Are you working out? Or shall I start immediately? Are you giving a try? Or shall I start immediately? निर्मल इज सेइंग 3. बेटा आप ऐसा कर सकते हो, निर्मल के वैल्यू ऑफ 3 सब्स्टिट्यूट करो यहाँ पर और एवरेज वेटिंग टाइम SRTF से आर यू एबल टू गेट इट एज 1 मिलीसेकंड और नॉट, यू कैन चेक. दैट इज अ काउंटर वे यू कैन चेक. हाँ, वेरी गुड युवराज, ट्राई कीजिएगा. निर्मल, you take burst time of process P4 as 3, prepare the Gantt chart and compute the average waiting time and check are you getting 1 millisecond or not. That is the best way of verifying your answer whether it is right or wrong. Good evening, Pawan. Yuvraj, any answer from your side? Okay, very good. Now I'm starting it off. Boys and girls, please have a look. Start करेंगे because I want to solve a couple of more problems in today's session. So more interesting questions I'm going to work out. So please have a look on board. चलिए start कर रहा हूँ SRTF at time 0. So SRTF At time 0, which process are we going to start with first? P1. P1 is going to run till 1 unit. क्योंकि at time 1 we are getting P2, इसका balance बचेगा 2 units and P2 is smaller, so P2 run करेगा for 1 unit and going to finish at time 2. At time 2, we don't have P3 and we don't have P4, so we have only P1. So P1 run करेगा. Till what? Till time 3. Very good, Pawan. So P1 is going to run till time 3. अब यहां पर देखिएगा time 3 पर P3 comes with requirement of 3. So definitely 3 is, और इसका balance बचेगा 1 unit. तो 1 is less than 3, so no preemption. मतलब P1 full अपना burst time run करेगा till 4. Right? Till 4. इसका balance था total 2, so 2 plus 2 4. So now P1 का balance है 0. P1 is over. P1 total because 1 plus 2 3 units it has consumed. P2 1 unit it has consumed. Now time is 4. Boys and girls, here we have an interesting aspect. Nirmal, I don't think 4 is the correct answer. Please have a look on board, Nirmal. At time 4, we have got P3 and P4. दोनों process available है. तो दोनों में से कौन run करेगा? Essentially will be decided by the value of burst time 3 and Z. अब Z की value तो हमें पता नहीं है. Z की value we don't have. Yes, Pawan Kumar is right. So we don't know the value of Z. So therefore the conditionally आपको ने work करना पड़ेगा. First condition I say, imagine that if Z is less than 3. अगर हम imagine करें कि Z is less than 3, तो कौन रन करेगा? P4 रन करेगा. कितने टाइम के लिए रन करेगा? Z यूनिट्स हमें ऐड करना है, मतलब 4 प्लस Z. P4 रन करेगा फॉर 4 प्लस Z. फिर उसके बाद लास्ट में P3 रन करेगा फॉर 3 यूनिट्स. 3 यूनिट्स हमें इसमें ऐड करना होगा, सो इट विल बिकम 7 प्लस Z. ये हमारा गैंट चार्ट है विथ रिगार्ड टू केस इफ Z इज लेस देन 3. सो अगर हम जब मान के चल रहे हैं कि Z वैल्यू इज लेस देन 3, then this is a scenario. ये बेसिस पर हम इवेलुएट कर लेंगे कि what is the average waiting time and equate it to 1. तो चलिए यहां पर हम एवरेज वेटिंग टाइम निकालेंगे. एवरेज वेटिंग टाइम इज इक्वल टू एज पर द गैंट चार्ट. P1 का वेटिंग टाइम कितना है? इनिशियली ये टर्म के लिए तो कोई भी नहीं है, यहां से यहां तक 1 यूनिट के लिए P1 हैज वेटेड, यहां से यहां तक. सो P1 का वेटिंग टाइम है 1 प्लस P2 हैज 0 वेटिंग टाइम. P3 देखिएगा came at time 3. P3 came at time 3. It got scheduled at Z 4 plus Z. It got scheduled at 4 plus Z. मतलब 4 plus Z starting from 3. Right? 3 to 4 plus Z. मतलब Z plus 4 minus 3. Z plus 1. Z plus 1 is the waiting time of P3. Z plus 1 is the waiting time of P3. फिर इसके बाद क्या होगा? कौन रन करेगा? P4 के लिए. P4 came at 4 and got scheduled at 4. So P4 का भी waiting time 0. This is the total waiting time divided by number of processes 4. तो ये आपका क्या बनेगा इक्वेशन? You want average waiting time to be 1. So 1 is equal to Z plus 2 by 4. तो जब आप यहां पर सॉल्व करोगे इक्वेशन, if you solve this equation, 4 is equal to Z plus 2. So therefore Z is equal to 4 minus 2 is equal to 2. Your answer is 2. ठीक है ना? So how you get the answer as 2, you can check from here. आप इसके साथ साथ ये भी काउंटर टेस्ट कर सकते हो. सर आपने कहा Z is less than 3, आपने इस तरीके से गैंट चार्ट बनाया. It is possible that Z may be greater than 3. हाँ सर, ऐसा भी हो सकता है. So I am leaving this as an exercise to you. I am telling you what is going to happen. In the second case, अगर ये गैंट चार्ट में if you would have assumed that if Z is greater than 3, आप चेक करोगे, you can counter check that the average waiting time of the processes will become greater than 1, and that is not possible. क्योंकि average waiting time दिया गया है is 1 millisecond. So if Z become greater than 3, जब आप गैंट चार्ट बनाओगे, you will find that the average waiting time will be greater than 1, which is impossible. So therefore हमारा ये जो कंडीशन हम अज्यूम कर रहे हैं, that is correct. That will give you the value of burst time as 2 units. और एक भी आप काउंटर मेजर कर सकते हो. You can cross verify by putting the value of Z is equal to 2 and redrawing the Gantt chart. आप फिर से Gantt chart बनाइए. then you will get the same answer. You will get the same Gantt chart. This will become 6, that will become 9, and then finally you calculate the average waiting time, आपको value आएगी 1 millisecond. So this is how you can counter test whether what you did is right or wrong. ठीक है, एक और इंटरेस्टिंग क्वेश्चन लेंगे बच्चों. So what is that interesting question? Please have a look. This is an interesting question where आज के दिन भी जब मैं क्वेश्चन देता हूं स्टूडेंट्स को, many students make a very, what do you say, blunder mistake. Blunder, they do go wrong. तो देखेंगे आपकी क्लास में. रिमेनिंग टाइम आई वुड लाइक टू वर्क आउट दिस क्वेश्चन, दिस प्रॉब्लम, बिकॉज आई सॉ मेनी स्टूडेंट्स मेकिंग मिस्टेक इन दिस क्वेश्चन, so I would like to solve it here. Consider processes P1 and P2 arriving in the ready queue at time 0 with the following properties. This is not exactly gate question, लेकिन कोई एक कॉम्पिटिटिव एग्जाम का क्वेश्चन है, इंटरेस्टिंग क्वेश्चन है. So please try to see. P1 needs a total of 12 units of CPU time. So P1 needs burst time of 12 units of CPU time and 20 units of IO. This is CPU and CPU scheduling और IO scheduling दोनों का कॉम्बिनेशन है. CPU burst है और IO burst है, दोनों है. After every 3 units of CPU time, P1 spend 5 units of time on IO. तो मतलब आपके जो 12 units of CPU time है, that is going to get splitted into units of 3, 3, 3, 3, 3, 3, 3 like that. So after spending 3 units of CPU time, then process spend 5 units of time on IO. फिर 3 units of CPU time, फिर 5 units. इस तरीके से साइकिल चलते जाएगी प्रोसेस P1 की. P2 का क्या सिचुएशन है? P2 needs a total of 15 units of CPU time and no IO, no IO. So मतलब P2 का सारा का सारा बर्स्ट टाइम है, CPU बर्स्ट टाइम है P2 का. P2 अराइव जस्ट आफ्टर P1. P1 पहले आएगा रेडी क्यू में, फिर P2 आएगा. फिर देखिएगा, डेटा इज वेरी डायरेक्टली गिवन, वेरी कंफर्टेबली गिवन, वेरी क्लीनली गिवन. बहुत क्लीन डेटा है. कंप्यूट द कंप्लीशन टाइम्स ऑफ P1 एंड P2 यूजिंग 2 शेड्यूलिंग टेक्निक्स. एक है SRTF, दूसरा है राउंड रॉबिन. बच्चों मैं सॉल्व करूंगा SRTF, एज ए होमवर्क आप ट्राई करोगे राउंड रॉबिन. ठीक है, और अगर आपको कोई दुश्वारी हो, कोई मुश्किल हो, देन मेरे टेलीग्राम चैनल पर आप मुझे DM कर सकते हो, ग्रुप में कम्युनिकेट कर सकते हो, देन आई कैन रेस्पॉन्ड टू यू. यस पवन कुमार, व्हाट यू आर टेलिंग इज परफेक्टली करेक्ट. व्हाट यू आर टेलिंग इज परफेक्टली करेक्ट. अगर आप Z की वैल्यू ग्रेटर देन 3 लोगे तो एवरेज वेटिंग टाइम विल बिकम ग्रेटर देन 1. दैट इज करेक्ट. तो चलिए बच्चों गैंट चार्ट बनाएंगे SRTF के लिए. सो यहां पर हम आई विल स्टार्ट. काइंडली पे अटेंशन, वेरी इंटरेस्टिंग क्वेश्चन. So I will first put process number, arrival time, burst time. ठीक है, 1, 2 दो ही प्रोसेस है. एंड यहां पर देखिएगा burst time then IO burst time, इस तरीके से है प्रोसेस का. ठीक है, तो यहां पर फिर से एक बार देख लेंगे. So time starts at 0, ready queue in time 0. टाइम 0 है. चलिए, so time 0, 0. And the burst time of P1 is 3 and 5. They're repeating. And this is directly 15 units. 15 units of time, no IO. Total burst time is 15 units. No IO. तो फिर से एक बार रीएम्फसाइज कर रहा हूं मैं. निर्मल, यस यू कैन प्लेस योर डाउट, नो प्रॉब्लम. तो दिस इज 3 + 5. फिर नेक्स्ट साइकिल में फिर 3 + 5 जाएगा. नेक्स्ट साइकिल में फिर 3 + 5. नेक्स्ट साइकिल में फिर 3 + 5 जाएगा. इस तरीके से आप रन करोगे P1 को 3 and 5. CPU बर्स्ट, IO बर्स्ट. तो टोटल 12 यूनिट्स ऑफ बर्स्ट टाइम होना चाहिए P1 का. P1 का टोटल 12 है और IO बर्स्ट टाइम है 20. IO बर्स्ट टाइम है 20. देख लीजिएगा क्वेश्चन में. टोटल 12 यूनिट्स एंड 20 यूनिट्स ऑफ IO. अब देखेंगे 12 यूनिट्स कंप्लीट हो गए. 1 2 3 4 12. 1 2 3 4 20. ये है लाइफ साइकिल ऑफ P1. ये है लाइफ साइकिल ऑफ P1. सो P1 फर्स्ट विल रन फॉर 3 यूनिट्स ऑन CPU, देन 5 यूनिट्स ऑफ IO. ये 5 यूनिट्स ऑफ IO कंप्लीट होने के बाद ही फिर 3 यूनिट्स आएंगे. यू आर नॉट गोइंग टू कंबाइन दिस 3 + 3. यू आर नॉट गोइंग टू कंबाइन दिस 3 + 3 + 3. आई एम वेरी क्लियरली टेलिंग दिस. और यहीं पर बच्चे मिस्टेक करते हैं एंड दे गो रॉन्ग. तो कैसे बनेगा गैंट चार्ट? प्लीज हैव अ लुक. आई एम डूइंग इट हियर. And imagine this is the ready queue. So boys and girls, may I have your attention please? This CPU, time 0. At time 0 in the ready queue, I have P1 followed by P2. टाइप ऑफ शेड्यूलिंग इज SRTF. काइंडली रिमेंबर SRTF वर्क कर रहे हैं हम. टाइम ऑफ शेड्यूलिंग इज SRTF. आई मीन द CPU शेड्यूलिंग टेक्निक इज SRTF, शॉर्टेस्ट रिमेनिंग टाइम फर्स्ट. एट टाइम 0 आपने कहना होगा कि विच प्रोसेस इज गोइंग टू रन फर्स्ट. P1 का बर्स्ट टाइम है 3 एंड P2 का बर्स्ट टाइम है 15. P1 will not compete with 15. That is a mistake. P1 will not compete with 12. That's a mistake. P1 will compete with 3 units क्योंकि उसका करंट राउंड में जो बर्स्ट टाइम है वो है 3. So 3 and 15 are compared, boys and girls. 3 is less. So therefore P1 starts and P1 runs for 3 units. And P1 will go for IO now. 5 units. मतलब उसका IO कंप्लीट होगा 8. Meanwhile P2 is going to run on CPU. P2 रन कर पाएगा 5 यूनिट्स के लिए. क्यों? क्योंकि 5 यूनिट्स तक रन करने के बाद क्या होगा? 5 यूनिट्स तक अगर रन करा 8, इसका बैलेंस बनेगा 10. लेकिन एट टाइम 8 P1 कंप्लीट इट्स IO एंड जॉइंस द रेडी क्यू. और P1 का सेकंड बर्स्ट क्या है? 3 यूनिट्स. तो 3 and 10 आर कंपेयर्ड. 3 is less. So therefore P1 will take the charge. ये ब्यूटी है कॉन्सेप्ट की of this question. I hope you are following my point. So P1 completed IO at time 8 and joined the ready queue. And then immediately P1 compete with 3 and 10. 3 and because P2 has run 5 units, so 5 हम subtract करेंगे 10. So among 3 and 10, 3 is shorter, shortest remaining time first. 3 shorter मतलब P1 फिर रन करेगा 3 यूनिट्स के लिए 11. इसके बाद अपना सेकेंड IO के लिए जाएगा P1 सेकेंड IO. कितने? 5 यूनिट्स अगेन. 11 plus 5 16. फिर इसके बाद कौन रन करेगा? P2 is only available, so P2 रन करेगा कितने यूनिट्स के लिए? 5 यूनिट्स के लिए. 11 plus 5 16. फिर at time 16 what is going to happen? P1 again comes into the ready queue. P1 again comes into the ready queue. देखिएगा P1 थर्ड इंस्टेंस के लिए आया है. So P1 has completed this, has completed this, has completed this, has completed this. Now it has entered the ready queue with this data. Not this, only this data. So again it will compete with 3 and so balance is how much here? So P2 has run for twice, 5 plus 5. So balance is 5 units. So we are going to compare 3 and 5. 3 and 5. 3 smaller. So यहाँ पर फिर preempt होगा. This was preemption of P2. So P1 will take the charge. P1 will take the charge. And P2 gets preempted back to the queue. And it will run for again 3 units, 19. फिर P1 will go for IO operation. Third IO for 5 units. 19 plus 5, 24. 19 plus 5, 24. Third IO this is. Now on this P2 is going to run. P2 का balance है 5. 19 plus 5, 24. 24 time units पर P2 has completed its execution. Very good Yuvraj, very good Pawan. P2 has completed at 24. Excellent answer. I'm very happy about it. फिर इसके बाद क्या होगा बच्चों? देखिएगा P2 is over now. Now P1 alone is remaining. तो P1 का क्या होगा? P1 completes at 24 and joins the ready queue. तो फिर अपना 3 यूनिट्स के लिए रन करेगा 27. फिर इसके बाद अपने लास्ट IO के लिए जाएगा P1. लास्ट IO 5 यूनिट्स. तो 27 plus 5 32. तो मतलब बच्चों यहां पर 27 to 32 यूनिट्स के लिए क्या होगा? There is no P2. P2 is already completed. मतलब we are going to have idleness here. No, yeah, nobody is there available. So up to 32 is idle. At time 32 P1 completes IO and joins the ready queue again, and it is going to run, right? Going to run for negligible time and complete its execution because completion जो होगा प्रोसेस का रनिंग स्टेट से होगा. It won't complete from block state. So it runs for negligible time 32 and complete. So therefore this is the completion time of process P1. This is the completion time of process P1. This is the completion time of process P2. So let me write down here. P1 completes at time 32 and P2 completes at time 24. So this is our final answer. This is our final answer. ठीक है? These are all final answer. So like that, in the handout, I have left over some more questions for you to practice. You can do that. This is also a similar question. जो अभी question हमने solve किया, उसी के ऊपर similarity के ऊपर एक question है. I want you to work out as a homework. और अगर आपको डाउट हो तो आप मुझे कांटेक्ट कर सकते हो टेलीग्राम चैनल पर. आई विल ट्राई टू वेरीफाई एंड लेट यू नो. So like that you can try more questions. This is also a theoretical question. Let us try to review this question now and work out. एक theoretical interesting question है. This is an MSQ from PYQ. MSQ of PYQ. Please try to work out. Which of the following statements is or are correct in the context of CPU scheduling? MSQ है is or are. तो मतलब context of CPU scheduling में इनमें से कौन से choices are true, are correct? Come on, give me the answer, boys and girls. What is the correct answer for this? Which of the following statements is or are correct in the context of CPU scheduling? In the context of CPU scheduling, can I say that the goal is to maximize CPU utilization? ठीक है, this is okay. And minimize throughput? नहीं, this is totally wrong. जब आप CPU utilization maximize करोगे तो throughput बढ़ेगा आपका. Throughput will not get decreased. So therefore that is contradicting. Second statement, second part of the statement is contradicting. ये wrong है. Turnaround times include waiting time. Yes. What is the formula for turnaround time? Turnaround time is equal to completion time minus arrival time. Waiting time का formula क्या है? Turnaround time minus turnaround time निकालोगे तो turnaround time is equal to waiting time plus burst time. Another formula. Another formula. So turnaround time includes waiting time. Definitely it includes. So this is correct. Implementing preemptive scheduling needs hardware support in the form of interrupt. So therefore that is also perfectly correct. Round robin policy जो अभी हमने देखा can be used even when the CPU time requirement by each of the process is not known a priori. A priori का मतलब है beforehand. अगर प्रोसेसेस की अगर आपको टोटल बर्स्ट टाइम पता ना हो, क्या हम राउंड रॉबिन इंप्लीमेंट कर सकते हैं? हाँ सर, बिल्कुल कर सकते हैं. दैट इज व्हाट इज द मीनिंग ऑफ द स्टेटमेंट. अगर आपको पहले से ही बर्स्ट टाइम प्रोसेसेस के पता ना हो, क्या हम राउंड रॉबिन इंप्लीमेंट कर सकते हैं? बिल्कुल कर सकते हैं. सो दैट इज व्हाट द चॉइस इज सेइंग. सो देयरफॉर दिस इज आल्सो ट्रू. सो एज ए एमएसक्यू द करेक्ट ऑप्शन फॉर दिस इज बीसीडी. बीसीडी. तो इस तरीके के यू कैन वर्क आउट. सो दिस इज द एंड ऑफ द सीपीयू शेड्यूलिंग चैप्टर बच्चों. So next class or next session में I will start with synchronization. Very important topic in operating system. Synchronization की सीरीज स्टार्ट करेंगे. ठीक है, गेट पर्सपेक्टिव से. और एक मैं प्रोग्राम लेकर चल रहा हूं इन अनअकैडमी ऐप फ्री क्लासेस में, जिसका नाम है ऑपरेटिंग सिस्टम कॉन्सेप्ट्स एकेडमिक सीरीज. अगर आप इंटरेस्टेड हो, दो स्टूडेंट्स हु आर परस्यूइंग देयर ऑपरेटिंग सिस्टम कोर्स इन देयर सेमेस्टर, या फिर जो सिविल, मैकेनिकल, इलेक्ट्रॉनिक्स, इलेक्ट्रिकल के स्टूडेंट्स हो, अदर ब्रांच स्टूडेंट्स हो, अगर वो गेट कंप्यूटर साइंस लिखना चाह रहे हैं तो उनके लिए भी एक एकेडमिक सीरीज विल बी वेरी मच यूजफुल. सो इफ यू वांट यू कैन डाउनलोड द अनअकैडमी ऐप and then you can watch the free classes there. So it is conducted regularly on Saturday and Sunday along with this Naya Agaz series, right? So if you are interested in that academic series, you can watch that also. यहाँ पर ज्यादा ओरिएंटेशन गेट का है, वहां पर जो ऑब्जेक्टिव है फाउंडेशन कॉन्सेप्ट्स ऑफ ऑपरेटिंग सिस्टम पर फोकस किया जा रहा है. फाउंडेशन कॉन्सेप्ट्स, बेसिक कॉन्सेप्ट जो बच्चे फर्स्ट ईयर सेकेंड ईयर के जो है, राइट. हाँ, स्पेशल क्लास में कभी कभी, हाँ बिल्कुल ही ऐसा हो सकता है. तो इसलिए आप, हाँ मेरा निर्मल, आई हैव ऑलरेडी गिवन माय टेलीग्राम आईडी, यू कैन हैव इट. लुक हियर also in the PDF I have put my telegram ID. You can have a look here. This is my telegram ID. So on this telegram group of mine I will upload this PDF also. उसमें वहां पर मैं PDF भी अपलोड करूंगा. युवराज सिंह, एक्चुअली प्रॉब्लम यह है कि देयर आर अदर सेशंस आल्सो गोइंग ऑन, सो देयरफॉर दैट इज व्हाई वी आर बेसिकली व्हेनेवर आई एम गेटिंग टाइम आई एम पॉजिटिवली कंडक्टिंग दिस सीरीज. ठीक है, कोशिश ये करूंगा एटलीस्ट अगर लाइव ना हो तो रिकॉर्ड करके आपको प्रीमियर कर दूंगा वीडियो. आई विल ट्राई माई लेवल बेस्ट. ओके युवराज, आई विल डू माई लेवल बेस्ट. तो ये टेलीग्राम आईडी पर मैं PDF भेजूंगा, यू कैन डू इट. and you can watch that academic series also on the special classes of Unacademy app. ठीक है? हाँ बिल्कुल पवन, you can watch in recording mode, and if you have any questions, any doubts, you can answer me. ठीक है? तो चलिए बच्चों, आज का सेशन यहीं क्लोज करेंगे और नेक्स्ट क्लास में मैं सिंक्रोनाइजेशन स्टार्ट करूंगा. ओके, थैंक यू सो मच, टेक केयर, गुड नाइट.